For learning objective B, I'm going to show you how to make the residual plots on your calculator. So here we have some data where we're dealing with our X and Y information. X is days and L is going to be time in minutes. And what they did here is they measured the length of each day from sunrise to sunset in minutes at a city in the Northern Hemisphere, and they did it every 10 days for 100 days. And they started on August 31st. So on August 31st, on day 0, from sunrise to sunset, the day lasted 793 minutes long. 10 days later, the day was shorter. 20 days later, from the beginning, the day was even shorter. So what we're going to do is we can plot a scatter plot from this. So just a review on how to do the scatter plot, because we first want to look at the data set. We're going to click on Stat and hit Edit. Again, we're going to have the days be in list 1, the minutes in list 2. Make sure they're lined up as proper ordered pairs. Now to make the scatter plot, we're going to use the graphing buttons at the top. We want to get to Stat Plot, which is above the Y equals. Stat Plot is in the blue, and so is my second button. So to get there, I hit second Y equals, and I'll get to this screen. Hit Enter and get into the details. Once you get into these details, make sure to click on, otherwise it's not going to run. You're going to arrow down to here and choose the scatter plot. Make sure you tell it where your X and your Y data is. Mine is in list 1 and list 2. And then you can mark it accordingly. Now I recommend, again, clicking on the zoom button. When you go to the zoom button, this is going to show up down here. Number 9 is zoom statistics. It helps you find your stats. So if you hit zoom stats, you're going to get this picture of the scatter plot. So when you look at it, it looks like it might be a linear graph with a negative slope. But look at this little curve here too. Maybe it's actually exponential decay where it's going to curve down like this. Or maybe it's actually going to be a quadratic where it curves down and maybe it's going to pop back up and have that pattern. So what we need to do is we need to run 3 regressions. We're going to run a linear, a quadratic, and an exponential. We're going to record the equations from each of them. And then we are going to graph and look at the residuals and make a decision on which graph is the best model to predict how long the days are going to be. So let's just do the linear regression first. So here's what you need to do. You actually have to run the regression, otherwise it won't work. So we have to go back to Stat, and this time we're going to select Calculate, just arrow to the right. Let's go linear regression first, which is number 4. This screen will pop up. Make sure you have your X's and Y's in the right list. Frequency is blank. Hit Calculate. Now when you hit Calculate, we're going to have the equation right here, and we can jot that down. It's just going to be Y equals negative 2.45x plus 786. Okay? Where again, X is how many days have gone by, Y is the minutes. Now to graph the residual plot, we're going to go back to that scatter plot. So I'm going to go second stat plot. We're going to get up to here. Enter into this again. Now what we need to do is we're going to keep it on, do a scatter plot. My X's are list 1. The only change we need to make to this is I have to change the Y list to this word residual. Now don't type the letters to spell residual. The word residual is actually stored in your calculator. And where you're going to find it is you are going to want to go to second stat. We're trying to get to this little list button here. So again, to get to here, go to second stat, and you should see L1, L2, L3. You might even have more information, and you may have to scroll down till you see the word residuals. Once you do that, then just know where they are. So exit out of that. You can do second quit. Now, I want us to go back into this stat plot. So if you're out of it, let's go second stat plot, click enter into this, go back here. Scroll down to the Y list. We are going to go find that word residual again and put it in there. So to put it in there, have your cursor at the Y equals list. Just go and click second stat or the list, scroll down to the residuals or hit number 7, and it will automatically populate the word there. Okay, now we're ready to graph it. We do want to go back before we graph to click the zoom and go zoom stats. When you zoom the stats, you're going to get a picture of the plots of the residuals. What I would do is make a rough sketch of this if you're doing an analysis. Now, my gut feeling says this linear is not a great model because I see kind of this pattern of the residuals and I don't like that. Okay, let's go analyze another model. Let's do the exponential model. Now, that residual button that we found actually stores the residuals for the last model that we ran. So if you don't do anything to your calculator, it's going to have those residuals for the linear model. So what we have to do is if we want to check out the exponential model, we're going to go run it. So I'm going to go stat, calculate, exponential, scroll down to number 0. Okay. Again, your X list should be if list 1 and list 2, if that's what you use, and hit calculate. From that, we can get the model, and I'm going to jot that down. Y equals at 792 point, I'll do 63. The base here is 0.9963 to the x power. By the way, it's exponential decay, which we expected. Okay. Now, let's look at the residual plot. Go to second, y equals or stat plot, click on the plot, and get into this detail. Now, if the word residual isn't there, you should put it back, but if you haven't done anything, it's still there. Now here's what you want to make sure not to do. Do not go and do zoom statistics again. If you're comparing 3 different graphs, you only do zoom stats on the very first residual plot, not the other 2, because we need to have the same window on the x-axis. If you do zoom stats on the second residual plot, it's going to change to match this data better, so don't do that. All you have to do now is you want to click on the graph button. So don't do zoom stats. When you hit graph, you're going to see the same x-axis and y-axis measurements that we did for the linear, but this is for exponential. I would sketch this down on your paper to get a picture of it and look at how it compared to the linear. This one still has a pattern that I don't like, but it's closer and tighter to the x-axis, so it is better. Let's look at the last model. Okay, now we have to run the quadratic model. Don't forget to run the model, otherwise the residuals won't reflect the right model. So to do that, again, just stat, calculate. The quadratic is quad reg, so number 5. When you run it, choose the appropriate x and y lists and hit calculate. And here's our equation. So I'm going to write this down. X squared minus 3.15x plus 796.55. So this is the model to predict for quadratics. Okay, let's look at the residual plot. So I'm going to go back to second, y equals, and make a new stat plot. I get in here, and I didn't make any changes, so my y still says residual. Again, if it doesn't, you're going to have to go second, list, or stat, find the residual button, word, and put it in there. Now again, don't do zoom stats. Go right to graph. Now this is the comparable XY axis. Sketch this picture, and then we're going to compare all 3 residual plots and make a final decision. Okay, here's the final output that we came up with. Looking at the residual plots, I would think you would say that we can nix the linear one right away. There's way too much spread in here. We have all of this spread in here and this major parabolic pattern. Now it looks like it's going to come down to the exponential or the quadratic, and they look very similar in terms of pattern. What I would say, this is a tough one, but for sure the quadratic would be the winner, and here's why. The quadratic model here has a slightly tighter pattern along the x-axis with the residuals than the exponential does. This guy right here is a lot of error. And I like how this is kind of, on the low end we have some residuals, and then the high end we have residuals. So it's very consistent on both the top and bottom. I mean, it is a close call, but I do think that this is probably the indicating part that really makes it stick out for me, and that's why I would choose the quadratic.